All right, welcome back, Math 8. Today we are continuously learning about rate. So, a little bit of a recalling. Oh, and by the way, this is workbook page 34. The difference between ratio and rate is rate, you can use column notation ratio, you can use column notation or fraction. When it comes to rate, people generally use fraction because of two reasons. When it comes to fraction, you have numerator and you have denominator. In rate, numerator have certain unit, I'm going to call unit 1, and denominator have unit 2. And it has to be completely different. So when it comes to ratio, you can use the same unit. How many vote goes to, let's say, this party compared to the other party? It's the same unit. On the other hand, when it comes to rate, if it's vegetable price, how much money, dollar sign on the top, and how many gram at the bottom. Or if it's certain fruit that is countable, you got the idea. Now, today what we're going to learn is known as proportional reasoning, which is basically similar concept as equivalent fraction, but I'm going to call equivalent ratio. And we're going to do several classic examples. First of all, when people say proportion, that means a certain change equally applied to another factor. So what I mean by that is, I want you to look at this example. On the left side, you have 2 over 3. On the right side, you have 6 over 9. If I compare the number between the first and second, just a numerator, the change is 2 times 3. This is what I like to say, change for your numerator. But if you look at the denominator, can you see the change is also equally applied? 3 times 3 is 9. If the change for the first number and second numbers are equal together, this relationship is what we call proportional relationship. And that occur equally when it comes to your rate too. Can you see 2 kilometers over 3 hours is equivalent to 6 kilometers per 9 hours? Because in the end, this most basic simplified rate, that rate relationship do not change, which is if I use a ratio, it's 2 to 3 ratio. It doesn't change. Let's do classic example together to explore about this proportional reasoning section. I have a question. Electricity costs 11.58 cents for 2 kilowatts. How much does 30 kilowatts cost? So first thing first, whenever you see some kind of rate, I highlight it, because that gave me 2 units. It doesn't matter which one you put on the top, but generally I put the first one on the top, second one at the bottom. Then you will have cent 11.58 over 2 kilowatt. Some of you guys may not know the unit, but who cares in the end? As long as this kilowatt repeat on the other section, and yes, we do. In that case, we don't need to convert any of the unit. But the position is quite important. Where did we put kilowatt? We put kilowatt as a denominator. Then you should do the same thing. 30 goes up here, and on the top, if you don't know, put X, whatever the amount that you try to find. But the unit for the unknown should be cent, however, because they are located on the top. This is your first step. Now your next step is, we did it yesterday, and the day before, opposite operation. Or if you want to do easier way, and if that work, you can also do like what we are doing, proportional reasoning. Because our title is proportional reasoning, why don't we go there? Look at the bottom numbers relationship. 2 turning into 30. What kind of multiplication or division relationship do we have? First of all, the number goes smaller to big, so it must be multiplied. And I want you to think about 2 times something that become 30. What is that number? And this is where your mental math coming in, right? Or other way, 30 divided by 2. What is that? It is multiplied by 15. Now that means if we have a rate, and if we are changing into different rate, if we are being consistent of the unit placement, then we learned that proportional reasoning is possible, which is the top number must be multiplied by 15 also. That means the x cost is actually cent 11.58 multiplied by 15. That's what you need to do. And this is basically your calculator time. 11.58 multiplied by 15 is equal to 173.70 cent or 173.7. Doesn't matter which one you use. Oh, actually, I almost missed. The question says answer to the nearest cent. So that means we gotta round it up actually. If you round it up to a whole number, then you know that it will be 174 cent. That's how much it costs for electricity. That's one example. And this is how we apply proportional reasoning. If it's the same type of rate, change into another. As long as you're consistent with the units, what goes on the bottom, what goes on the top, the change, multiplication, division relationship should equally apply. Let's do another example. On page 35, there are 72 players on 8 baseball teams. Determine the number of players on 2 teams. Show how to find the answer more than one way. So, this one, let's use 2 different ways. The first way, you know, proportional reasoning way. The other way is what we learned last time, which I like to call opposite operation. But it uses the same type of concept. First thing first, highlight some of the clue. There are 72 players on 8 baseball team. That give you one type of rate in this case, and the other one it says number of player on 2 teams. So let's do proportional reasoning first. 72 players, if you want to put it on the top, feel free. 8 teams. That's my fraction. That means my bottom, that 2 teams, should go at the bottom. Don't put it on the top. You shouldn't see diagonal. You should see on the same level. And on the top, you don't know. X is going on. Now let's look at what kind of number relationship is going on. From 8 to 2. Can you see that it's bigger number going to smaller number? Then it's not going to be multiplication. Going to be division. 8 divided by something become 2. What is that? There's only 1 divided by 4. That means we have same type of rates happening, same type of unit at the bottom and the top. So if I look at the top section, I should do exact same thing divided by 4. So that means x is equal to 72 divided by 4, which is, if you use your calculator, feel free. If you want to use mental math, feel free. Gonna use mental math. You can divide this by 4. It become 18. So you can say 18 players. That's one method. Other method. What you need to do is similar thing. Except this time, let's do opposite operation way. You want to isolate this x. That means I gotta get rid of this 2 at the bottom. X over 2 means x divided by 2. What's the opposite of division? It's multiplication. Then these guys will cancel out. Thus x is equal to 2 times 72 over 8. That's what you gotta do. Fortunately, 72 and 8, it's divisible. And it's in your multiplication table. 9 times 8 is 72, so both you can divide it by 8. And bottom is 1, so I don't need to think about denominator. 9 times 2, that's 18. Similar type of result. Let's do a, I guess one more, and then we can do the rest of them for the next class. A wildlife biologist wants to know how many trout are in slough in Saskatchewan. He captures and tags 24 trout and releases them back in the slough. 2 weeks later, he returns and captures 30 trouts and finds that 5 of them are tagged. He uses the following ratio to estimate the number. And we have the ratio that is given, fortunately. Fish recaptured with tag, total fish recaptured. Fish caught and tagged, total fish in slough. And the question asks you, how many trout does he estimate are in slough? So we're talking about this number at the bottom. Let's write down what we know first of all. And so let's go through clues that we know already. Let's figure out anything that is given first. Fish that captured with tags were given as 5. Total fish that recaptured was 30. And captured at the beginning, so 2 weeks before, and it was tagged was 24. And total fish, we do not know. Why don't we put F for fish? We're trying to find, and this time it's quite interesting because, first of all, proportional reasoning is tough to do because of one reason. If this is 25, I can say, you know what, 5 times 5 give you 25. That's easy to do. But 5 and 24, you have no relationship. And in addition to that, unknown variable is at the denominator. Then opposite operation can get a little tricky. Here's what we do. I want you to write this down. When you have a unknown variable at the denominator place, then you need to reciprocal. You need to flip. This process of flip in math is known as reciprocal. What I mean by that is this. I want you to flip bottom and top of that. And same thing for the other side. Because if you have an equal sign, whatever the change you're doing on one side should be equivalently go to the other side. Then you will have f over 24 is equal to 30 over 5. Then, can you see my top number is what we need to, top numerator is my unknown variable. Then, it's exactly same as a previous situation. I can do opposite operation by multiply by 24 on both sides, and these guys cancel each other. And then what I need to do is f is equal to 24 times 30 over 5 is what you need to do. And in fact, 5 and 30 you can simplify because both can be divided by 5. And what I have is 24 multiplied by 6, which is 144. And that's how much fish is total fish in slow. That's what it is. And that is today's lesson, folks.